Data analysis is like being a detective for numbers. You look at information or data to find interesting stories. These stories can help us understand things better. For example, a business might analyze sales data. They want to see which products are popular. Or a scientist might analyze experiment data. They want to find a new discovery. The main goal of data analysis is to take raw information. Then you turn it into useful knowledge. This knowledge helps people make smarter decisions. It is a process of inspecting, cleaning, transforming, and modeling data. This process helps highlight useful information and support decision-making. Today, data analysis is incredibly important. We live in an age where data is everywhere. Every click on the internet creates data. Every purchase you make generates data. This is often called the data explosion. Businesses use data analysis to understand their customers. They can improve their products and services. Scientists use it to make breakthroughs in medicine and climate change. Governments use it to improve public services. Without data analysis, we would be swimming in information. We would not know what it all means. It helps us find patterns and trends that we might otherwise miss. This makes it a vital skill in many fields. Python is a popular programming language for data analysis. Many people choose Python for several good reasons. Firstly, Python is known for being easy to read and write. Its syntax is simple and clean. This makes it a great language for beginners to learn. Secondly, Python is very versatile. This means it can be used for many different tasks, not just data analysis. It can be used for web development, automation, and scientific computing. Thirdly, Python has a very large and active community. This means if you have a question or a problem, you can easily find help online. There are many resources available to learn Python. Python offers specific advantages for data analysis tasks. One of the biggest advantages is its rich collection of libraries. These libraries are like toolkits that provide ready-to-use functions. For data analysis, libraries like Pandas, NumPy, and Matplotlib are essential. They make complex tasks much simpler. Python is also scalable. This means it can handle small datasets on your laptop. It can also handle very large datasets on powerful servers. Furthermore, Python integrates well with other technologies and systems. This makes it easier to build complete data solutions. These features make Python a powerful and practical choice for anyone starting in data analysis. To start your journey in data analysis, you need the right tools. A good development environment helps you write and run your code efficiently. It makes your work smoother and more organized. For many data analysts, especially those using Python, the Anaconda distribution is an excellent starting point. Anaconda is a free and open-source distribution of Python and R. It is specifically designed for scientific computing and data science. It comes with many popular data analysis libraries pre-installed. This saves you the trouble of installing them one by one. It also includes a package manager called Conda, which helps manage your libraries and environments easily. One of the most popular tools included with Anaconda is Jupyter Notebook. Jupyter Notebook is an interactive web application. It allows you to create and share documents that contain live code. You can also include equations, visualizations, and narrative text. Think of it as a digital notebook where you can write code, see the results immediately, and explain your work. The notebook is organized into cells. There are code cells where you write and execute your Python code. There are also markdown cells where you can write text, add headings, images, and links. This makes it very flexible for different kinds of content. Jupyter Notebooks are particularly beneficial for data analysis. Their interactive nature means you can run small pieces of code. You can check the output immediately. This is very helpful when exploring a new data set. You can try different things and see what works. Data analysis is often an iterative process. You clean some data, analyze it, visualize it, and then perhaps go back and clean more. Jupyter Notebooks support this iterative workflow very well. Moreover, they allow you to combine your code, results, and explanations in one place. This makes your analysis reproducible and easy to share with others, like colleagues or supervisors. Setting up Jupyter Notebook is quite straightforward, especially if you use Anaconda. Once you have Anaconda installed, you can open Jupyter Notebook from the Anaconda Navigator, or you can open it from your computer's terminal or command prompt. You simply type and press Enter. This will open a new tab in your web browser. This tab shows the Jupyter file browser. From there, you can navigate to your working directory. You can then create a new notebook by clicking the New button and selecting Python 3. You are then ready to start writing code and analyzing data in your new interactive environment. Before diving into complex data analysis, it is crucial to understand the basics of Python programming. Python is designed to be readable. Its syntax is straightforward. This makes it easier for newcomers to grasp. One of the first concepts you will encounter is variables. Variables are like containers that store information. You can give a variable a name, like or. Then you can assign a value to it, such as or. Python is dynamically typed. This means you do not need to declare the type of a variable. Python figures it out automatically when you assign a value. This flexibility is helpful for rapid development. Python supports several fundamental data types. These types define what kind of values a variable can hold. Common data types include integers, which are whole numbers like 10 or -5. Floats, or floating point numbers, represent numbers with a decimal point like 3.14 or -0.5. Strings are sequences of characters used for text like hello world. Strings are enclosed in single or double quotes. Booleans represent truth values. They can be either or. You can perform various operations on these data types. For example, you can do arithmetic with numbers. You can concatenate strings, which means joining them together. Understanding these basic types is essential for working with data. Control flow statements are vital for directing the execution of your program. Loops are a fundamental part of control flow. They allow you to repeat a block of code multiple times. The loop is used to iterate over a sequence. A sequence can be a list of items, a string of characters, or a range of numbers. For example, you can use a loop to process each row in a dataset. The loop is used to repeat a block of code as long as a certain condition is true. You also have conditional statements like else if, and. These allow your program to make decisions and execute different code paths based on specific conditions. Functions are another key concept in Python programming. A function is a reusable block of code that performs a specific task. You define a function once, then you can call it multiple times whenever you need to perform that task. Functions help to make your code more organized, modular, and easier to understand. They can take inputs, called parameters or arguments. They can also produce an output, called a return value. For example, you could write a function to calculate the average of a list of numbers. By breaking down your program into smaller, manageable functions, you can tackle complex problems more effectively and reduce code duplication. When you start working with data in Python, you will quickly encounter some powerful libraries. These libraries extend Python's capabilities for data analysis. NumPy is one such foundational library. NumPy stands for Numerical Python. Its main feature is the powerful n-dimensional array object, or. These arrays are more efficient for storing and manipulating numerical data than Python's built-in lists. NumPy provides many functions for performing mathematical and logical operations on these arrays. It is especially useful for scientific computing and any task that involves large numerical datasets. Many other data science libraries, including Pandas, are built on top of NumPy. Its speed and efficiency are crucial for performance. Pandas is arguably the most important library for practical data analysis in Python. It provides high-performance, easy-to-use data structures and data analysis tools. The two primary data structures in Pandas are series and data frame. A series is a one-dimensional labeled array, like a column in a spreadsheet. A data frame is a two-dimensional labeled data structure similar to a table in a database or an Excel spreadsheet. It has rows and columns. Pandas makes it easy to read data from various file formats like CSV, Excel, and SQL databases. It also provides a wide range of functions for cleaning, transforming, merging, and reshaping data. It is the workhorse for most data manipulation tasks. For visualizing your data, Matplotlib is the most widely used plotting library in Python. It provides a flexible framework for creating a wide variety of static, animated, and interactive visualizations. You can create common plots like line charts to show trends over time. Bar charts are useful for comparing quantities across different categories. Histograms help you understand the distribution of a single numerical variable. Scatter plots can show the relationship between two numerical variables. Matplotlib gives you a lot of control over the appearance of your plots. You can customize colors, labels, titles, and many other aspects. While it can be verbose for complex plots, its versatility makes it indispensable. Seaborn is another popular Python visualization library. It is built on top of Matplotlib. Seaborn aims to make it easier to create more attractive and informative statistical graphics. It provides a higher-level interface for drawing common statistical plots. This means you can often create sophisticated visualizations with less code compared to Matplotlib alone. Seaborn integrates well with Pandas data frames. This makes it simple to plot data directly from your data structures. It offers functions for visualizing distributions, relationships, and categorical data. Examples include box plots, violin plots, heat maps, and pair plots. Seaborn helps you create visualizations that are not only beautiful, but also statistically meaningful. Section 5. From raw data to usable insights, collection and cleaning. The journey of data analysis begins with data collection. Data can come from a multitude of sources. Businesses often store data in databases. Scientific experiments generate data files. Websites and applications provide data through APIs or application programming interfaces. You might also find data in publicly available datasets or collect it through surveys. When collecting data, it is important to consider its relevance to your analysis goals. You also need to be mindful of ethical considerations. This includes data privacy and ensuring you have the right to use the data. The quality of your analysis heavily depends on the quality of the data you collect. Once you have your data, the next step is often data cleaning. This is a critical and often time-consuming part of the data analysis process. There is a saying in data science, garbage in, garbage out. This means that if your data is messy or inaccurate, your analysis results will also be unreliable. Dirty data can contain errors, inconsistencies, or missing information. These issues can lead to misleading conclusions. Therefore, investing time in cleaning your data is essential. It ensures that your subsequent analysis is built on a solid foundation. Data cleaning involves identifying and addressing these problems to make the data suitable for analysis. One common issue in datasets is missing values. Data points might be missing for various reasons. Pandas provides tools to handle this. You can use the method to identify missing values in a data frame. Then you have a few options. You might choose to delete rows or columns with missing values using. However, this can lead to loss of valuable information if too much data is removed. Another approach is imputation. This involves filling in the missing values. You could fill them with a constant, like 0, or you could use the mean, median, or mode of the column. The method in Pandas is used for this purpose. The choice of method depends on the dataset and the nature of the missing data. Other common data cleaning tasks include handling duplicates, correcting data types, and addressing outliers. Duplicate records can skew your analysis, so they usually need to be removed. Pandas offers to find them and to remove them. Sometimes data is read with incorrect data types. For example, a numerical column might be read as text. You would need to convert it using methods like outliers are data points that are significantly different from other observations. They can be due to errors or represent genuinely unusual events. Basic outlier detection might involve looking at values far from the mean or median, or using visualizations like box plots. Handling outliers might involve removing them or transforming the data. Section 6. Digging deeper: exploratory data analysis, or EDA, and SQL fundamentals. After cleaning your data, the next exciting phase is exploratory data analysis, often called EDA. EDA is an approach to analyzing data sets to summarize their main characteristics. It is often done using visual methods. The primary goal of EDA is to understand the data better before you start formal modeling or hypothesis testing. You want to uncover patterns, spot anomalies or outliers, and check assumptions. It's like getting to know your data on a first-name basis. This process can help you formulate hypotheses that you can later test. EDA is an iterative cycle of asking questions about the data and using summaries and visualizations to find answers. A core part of EDA involves calculating summary statistics. These are numbers that summarize and describe the important features of your dataset. For numerical data, common summary statistics include the mean, median, and mode. These tell you about the central tendency of the data. You will also look at measures of spread or dispersion like the standard deviation, variance, and range. These tell you how much your data values vary. The Pandas library makes it very easy to get these statistics. The method on a data frame provides a quick summary of all numerical columns, including count, mean, standard deviation, minimum, maximum, and quartiles. While Python and its libraries are great for data analysis, many organizations store their data in relational databases. To access and manipulate this data, you often need to use SQL. SQL stands for Structured Query Language. It is the standard language for managing and querying relational databases. As a data analyst, having basic SQL skills is extremely valuable. It allows you to retrieve specific data you need for your analysis directly from databases. You can filter, sort, join, and aggregate data using SQL queries before even loading it into Python. This can be very efficient, especially when dealing with very large datasets stored in powerful database systems. Learning basic SQL commands is a good starting point. The statement is used to choose the columns you want to retrieve from a table. The statement specifies the table where the data resides. For example, would retrieve the name and age columns from a table named customers. The clause is used to filter rows based on specific conditions. For instance, would retrieve all columns for products that cost more than 100. Other important commands include for sorting results, for aggregating data, and for combining data from multiple tables. These commands form the foundation of SQL. Section 7. Painting the picture. The art and science of data visualization. Data visualization is a critical skill in data analysis. It is the practice of translating information into a visual context, such as a map or graph. This makes it easier for the human brain to understand trends, outliers, and patterns in data. A well-crafted visualization can reveal insights that might be hidden in tables of numbers. It's not just about making pretty pictures, it's about conveying information clearly and effectively. Visualization plays a key role throughout the data analysis process. It's used in exploratory data analysis, or EDA, to understand the data. It's also crucial for communicating your findings to others, whether they are technical or non-technical audiences. We have already mentioned Matplotlib as a foundational plotting library in Python. It gives you fine-grained control to create a wide array of charts. For example, scatter plots are excellent for visualizing the relationship between two numerical variables. Each point on the plot represents an observation. Pie charts can be used to show proportions of a whole, though they are best used with a small number of categories. Bar charts are effective for comparing quantities across different groups. Matplotlib allows you to customize almost every aspect of your plot. You can change colors, add titles to your chart, label your axes clearly, and include legends to explain different elements. This customization ensures your visualizations are informative. Seaborn, built on Matplotlib, simplifies the creation of more complex and statistically informative visualizations. It excels at producing aesthetically pleasing plots with minimal code. For instance, box plots are very useful for comparing the distributions of a numerical variable across different categories. They show the median, quartiles, and potential outliers. Heat maps are great for visualizing correlation matrices, showing the strength and direction of relationships between many variables at once. Pair plots, also known as scatter plot matrices, allow you to see pairwise relationships between several variables in a single figure. Seaborn's integration with Pandas data frames makes it easy to map data columns directly to plot aesthetics. Creating effective data visualizations is both an art and a science. The science part involves choosing the correct chart type for your data and the message you want to convey. For example, use a line chart for time series data, but a bar chart for categorical comparisons. The art part involves making your visualization clear, uncluttered, and visually appealing. Avoid misleading visuals, such as truncated y-axes or three-dimensional charts that distort perception. Always label your axes clearly and provide a title. Your goal is to tell a story with your data. A good visualization should guide the viewer to the key insights quickly and easily, making complex information accessible and understandable. Section 8. Making sense of numbers, statistical analysis, and a glimpse into machine learning. Statistical analysis provides the methods and theories to make sense of data, especially when there is uncertainty. A fundamental concept in statistics is probability. Probability measures the likelihood that an event will occur. It is expressed as a number between 0 and 1, where 0 means the event will not happen, and 1 means it is certain to happen. Understanding basic probability helps in interpreting data and making predictions. For example, if you flip a fair coin, the probability of getting heads is 0.5. Data analysts use probability to assess risks, understand variability, and build models that can generalize from observed data to new situations. Data often follows certain patterns or shapes, known as distributions. Common distributions include the normal distribution, often called the bell curve. Many natural phenomena follow this pattern. Understanding distributions helps you characterize your data and choose appropriate statistical tests. Hypothesis testing is another core statistical concept. It is a formal procedure for checking if your findings are statistically significant or if they could have occurred by chance. You start with a null hypothesis, for example, there is no difference between two groups, and an alternative hypothesis. Then, you use your data to determine if there is enough evidence to reject the null hypothesis. P-values and significance levels are key components of this process. Regression analysis is a powerful statistical technique used to model and understand the relationship between variables. It helps to predict the value of a dependent variable based on the values of one or more independent variables. Simple linear regression, for example, tries to find a straight line that best fits the relationship between two numerical variables. For instance, you could use regression to predict a student's exam score based on the number of hours they studied. The output of a regression analysis can tell you the strength and direction of the relationship. It can also be used for forecasting future outcomes. This is a widely used tool in many fields, from economics to engineering. Beyond traditional statistics, many data analysts are now also exploring machine learning, or ML. Machine learning is a subfield of artificial intelligence. It involves building algorithms that allow computers to learn from data without being explicitly programmed. There are two main types of ML. Supervised learning uses labeled data. This means the algorithm learns from data where the correct output is already known. Examples include classification, predicting a category like spam or not spam, and regression, predicting a continuous value like house price. Unsupervised learning uses unlabeled data. The algorithm tries to find patterns or structure in the data on its own. Clustering, grouping similar data points is a common example. Simple algorithms like k-nearest neighbors or KNN for classification and k-means for clustering are good starting points. Section 9. Charting your course projects, portfolios, and lifelong learning. Theoretical knowledge of data analysis tools and techniques is important. However, true mastery comes from applying that knowledge to real-world problems. This is where hands-on projects play a crucial role. Working on projects allows you to practice the entire data analysis workflow. You will collect data, clean it, explore it, model it, and communicate your findings. Start with small, manageable projects. As you gain confidence, you can tackle more complex ones. You can find interesting data sets on platforms like Kaggle, UCI Machine Learning Repository, or government open data portals. Choose projects that genuinely interest you. This will keep you motivated throughout the process. As you complete projects, it is essential to build a data analysis portfolio. A portfolio is a collection of your best work. It showcases your skills and experience to potential employers or clients. Your portfolio should demonstrate your ability to solve problems using data. For each project, include a clear description of the problem, the data sources, the methods you used, and the insights you found. Include your code, visualizations, and a write-up of your findings. Platforms like GitHub are excellent for hosting your code and project documentation. A well-curated portfolio is often more persuasive than just a resume. It provides concrete evidence of your capabilities as a data analyst. Beyond the core technical skills, there are complementary skills that are highly beneficial for a data analyst. Version control is one such skill. Tools like Git, often used with platforms like GitHub, help you track changes to your code and collaborate with others. Learning Git allows you to manage different versions of your projects. You can revert to previous states if something goes wrong. It also makes it easier to work in a team. Reproducibility is a key principle in good data analysis. Version control helps ensure that your analysis can be reproduced by others or by yourself at a later date. This builds trust and credibility in your work. Finally, remember that data analysis is a field that is constantly evolving. New tools, techniques, and best practices emerge regularly. Therefore, a commitment to lifelong learning is essential. Equally important are strong communication and storytelling skills. You might find amazing insights in your data, but if you cannot communicate them clearly and persuasively to others, their impact will be limited. You need to be able to explain complex findings to both technical and non-technical audiences. This involves creating clear visualizations, writing concise reports, and presenting your work effectively. By continuously honing your technical and soft skills, you can build a successful and rewarding career in data analysis.